Okay. Here's our first graphing problem. We're going to graph this. It's going to turn into a parabola, maybe opening up, maybe opening down. We got to find the vertex. We got to do a whole list of things. What's step number 1 in our notes from yesterday?
Find A, B, and C.
Yes, we need to do that. Step number 1 tells us we need to find the axis of symmetry and the vertex. That's what we did last night. We're always starting with that same process for all of these problems. In order to do that, we need to establish what's A, what's B, what's C. I think we actually started this problem yesterday, but it's fine doing it again. So what's A going to be? Yes, when there's no coefficient, we assume 1. B is going to be -6. C is going to be 4. Let's find the axis of symmetry. As x equals -b over 2a. See if you can figure that out. And I'll do it on the board on my own. Do we get +3?
Yeah.
Anyone need me to walk through how we got +3? It sounds like everyone was pretty good with that last night. It's the next step, finding the y of the vertex that threw people off. So let's go over that again. So we're looking for our vertex. We need an x and a y term. We already know that our x is 3 because our vertex lies on the axis of symmetry. So I know that the x term is going to be 3. X equals 3, but I'm going to plug that x term into y equals x squared minus 6x plus 4. Let's plug in 3 for our x terms. So I get 3 squared minus 6 parentheses 3 plus 4. This one's a little more straightforward because there's not as many negative signs. Order of operations tells us to do exponents first. 3 squared is 9. I'm going to skip ahead and kind of do 2 steps at once here. That's okay. This is 6 times 3, and I'm going to say minus 6 times 3 is 18. So it's minus 18 plus 4. I'm moving from left to right once I'm left with just adding and subtracting. 9 minus 18 is -9 plus 4. -9 plus 4, -5. So our vertex is 3, -5. Yes. That's what we worked on yesterday. Let's now actually plot these points on a coordinate plane. So for this one, all we need is, I don't know, let's go like 7 by 7. If you want to do 10 by 10, that's fine too. Better to give us a lot of room. So we're going to eventually be plotting points, and then we're going to connect them with our parabola. The key point is going to be the vertex. So we know the vertex is 3, -5. Let's plot that on our coordinate plane. So I'm going over 1, 2, 3, and down 1, 2, 3, 4, 5. So, and I'm going to label these points as I go. Now, the other piece of information that we know is our axis of symmetry. So let's draw that with a dotted line of where our parabola is going to be folded in half. And the axis of symmetry always, always, always goes right through our vertex. Okay. Questions so far? Step number 2 in our notes we took yesterday, it says plot the y-intercept. Now, in our notes yesterday, we talked about how our C term is our y-intercept, is the point where our parabola crosses the y-intercept. So our y-intercept is going to be at 4. Does everybody see that? Because C equals 4. So I'm going to go 1, 2, 3, 4. And this is going to be another point of our parabola. 0, 4, our y-intercept. Now, here's where we're going to utilize that axis of symmetry. All the points are going to be equal distant from our axis of symmetry. So if I know a point's over here, it's going to be perfectly reflected on the other side of our axis of symmetry. How far is this point from the axis of symmetry? It's 1, 2, 3. So now I'm just going to move 3 to the right. 1, 2, 3. There's another point of our parabola utilizing the characteristic of the reflection of the axis of symmetry. And it's always going to be on the same line in terms of y. So this point here is what? 1, 2, 3, 4, 5, 6, 6, 4. The last step, it says find 2 other points, use the axis of symmetry to reflect points. So we did that already with our y-intercept. Let's find one more point to plot so that we have a really nicely defined parabola. You could pick any point on our graph here for an x and plug in the y. But what I like to do is pick an x term that's in between my vertex and my y-intercept. So I could pick 1 or 2. Let's make it easy on ourselves and do 1. Okay, so we're doing x equals 1. We're going to plug that into our original equation and see what we get for y. And that's going to give us an x and y point. So I'm going to plug in 1 for x, x squared minus 6 parentheses 1 plus 4. One squared is 1 minus 6 times 1 is 6 plus 4. We're going to be doing this a lot, plugging things in and seeing what we get out for our y term. Moving left to right, 1 minus 6 is -5 plus 4, -1. So our point that we just found out in our parabola is +1, -1. Let's plot that point. 1, -1. Boom. Can we come up with another point from this one? What do you think, Molly?
I think it is. Wait,
I know it's kind of hard to see. I'm sorry.
1, 2, 3, 4, 5,
-5. That sounds right. So I'm looking to see how far this point is from our axis of symmetry. It's 2. So I'm going to go in 2. So it went 1, 2. Now I'm going to do 1, 2. There's our point. These points are equal distant from each other, thanks to our axis of symmetry. And I think Molly's right. It is 1, 2, 3, 4, 5, 5, 1. Excellent. Yes, thank you. Now we have some points. All we need to do now is connect them with a nice U shape known as a parabola. And that's it.
That was a big problem.
So we have graphed this equation.
That is a lot of work.
So on Monday, we were doing this already by plugging in points, -2, -1, 0, 1, and 2. That's one method. We could do the table method for this, but we can also utilize all these characteristics of a parabola and do it that way too. Finding the vertex, finding the axis of symmetry, finding the y-intercept, and reflecting some of those points on the other side of the axis of symmetry. I also want to point out that our parabola opens upward because our A term was positive.
Wow.
So it all makes sense and all connects. Thank you. Thank you. Thank you. Okay. I want you guys to practice this on your own, following these same steps, making sure that you are following the correct order of operation rules when you're plugging in an X and seeing what you get out for Y. Okay. I know it is, but we will take our time. There's no rush. I want you to do.
No. Billy. Billy. No, it's Billy.
Yeah.
Oh my God. No, you saw his hands.
I remember in school, I was at 30.
You've been kidding his arms.
How long does it take to go from 8:30 to 5:30? An hour.
My stomach hurts again.
And school ended at 2:10.
Can I have Billy back, please? Give me Billy back.
No, it's 40. Because you're stupid.
Luca, give me Billy back. Luca, Billy, give me Billy. You deserve that. Give me Billy. Give me Billy.
Okay, we got 15 minutes. Let's practice this before I set you free. Random problems, but 20, 22, and 23. I took these out of the textbook. So you please label them that way so I know what problem you're working on.
Do you have a pencil?
Once you grab the one on the desk.
Luca, give me Billy back.
This one?
Yeah.
So Billy. Billy's my one.
I would really like the one that was a distraction.
No, look, I've written the equation.
Good start.
Productive.